This is the demonstration of integrating WIPIMIS with the HTC VIVE. The first one is demonstration the scale whirling miniature technology. So first we need to calculate the height of angle as a bias of a reference.
Right.
So for example, I want to go to that particular white disk. So I raise my ankle to the control zone, so the wall will shrink until it reaches the desired scale, so that my next step, which is indicated by the red disk, can reach. And do the huge step, I transport to that particular location. Let me show you it again. Supposedly I will go to the disk on my left, so I rotate. I put the ankle into the desired control zone height until it's shrinking to the desired scale. I put down lock these things, but you can see I still can do the natural work here, but I want to make sure that I target it to the center. So it's difficult to control precisely if we can shift, and the run of error will accumulate. But for longer distance, it's easier to control in this way to get proximity, and we can use others work to reach the precise location. Now demonstrate again. Overshoot. It's okay because I told you that this is not a design for precise short distance reach, but it's designed for reach long distance proximity. For example, this one. Okay. Now let's demonstrate the next technology, which is scale disk mode, which uses the same idea of control the scaling, but the previous one scale the wall size down to a smaller one, so we can easily reach in a limit foot distance. This one we extend the virtual foot, so we scale it up until we can reach from the current location to next location in one step. So I'm waiting for calibration.
Calibration. Running.
Okay, so now again I want to reach the first disk. The same idea, I raise my ankle to the control zone. You can see the red disk is kind of extending. It's kind of a metaphor for my virtual foot. Once I extend my virtual foot into that desired stride length, so I do the quick step in the same place, then I will transport to this location. Again, let me show you the other one. You can also see that while I'm doing this virtual work, I can still using the VIVE's control to do the natural work. So there's no problem. I can integrate two technology together. So let's start from here rather than the disk. So again, I raise my ankle. A little bit overshoot, but I think I'm still okay. Another one. Sometimes there's a run of errors, or even from the user's spherical lens, it looks I'm in the right place. But after this run of error, there's certain things happen, so we cannot reach the exact target. So maybe theoretically, if we aim in the location where, so we should able to reach the position in one place. So there's some kind of ideal proof mechanism if we kind of offshoot our ankle. So we just leave this control zone. So when you put it down, like this one, so we are overshooting. So but you put it down, the scale will back to the original one. So we can just keep in doing this recalibration of your spending of disk. So in that case, even you mess up during the controlling your disk, you can put your feedback and to resume your disk control. Yeah. So for example, I can do this again to reach the location. Okay. Now the next test is to show a so-called air walking mode, which also use the idea of walking in place, but instead of change the scene of or the metaphor of your foot, it's just like the air walking. You lift your foot up, and you are doing the air walk or moonwalk, sliding over the floor until you put your foot down. So
Calibrating. I'm running.
okay. Now this is easier as long as you put you raise your ankle height over a certain threshold, then the avatar start to move like this one. Then when you reach the target, you put it down. So it's very simple. Now, in principle, if the audience can see from the, let me look down a little bit. There's a three bars. As long as I lift my ankle over the top of the brake bar on the left, it's moving. So I need to move. I don't need to raise too much. Let me do that again so you can see. So we are still moving, right? So I don't need to put all the way up. So actually it's very ergonomic. Okay, let's try. This distance from this target to another target is 40 meters. So if you use different kind of technology, that's a traditional or fixed length stride, you take several times to execute a series of steps, which will cause the fatigue and others issue with with the user. However, in our technology, you only put your ankle up to a certain degree or below this threshold to control your virtual wall is proves to be much easier to use, and also have less problem of fatigue. So it's very easy to reach the long distance, like say 40 meters. I just demonstrate. Last, I want to demonstrate the comparison of the previous technology to some other existing technology. For example, the sensor fusion working in place, which is invented by the Virginia Tech. Their idea is to do calibration and to take only 1/8 of the average stride length from the calibration, and every time they work in that fixed length.
Right. Step to the right to get back in frame. Okay. Calibrating. And run.
Okay. Now just their idea is just using the fit like the the switch, on-off switch, and each step they execute the running or working in the fixed length. Which in that case, if we consider the average length of the stripe is 40 centimeter, then in their case, they using 1/8 of every stripe as their virtual stripe. That means that each stripe length will be the 5 centimeter, which is good enough to reach some kind of small things. But however, you will see just for this 2.5 meters distance, you need to take a lot of steps, so it will cause the fatigue. So I won't finish all this traveling all the way to the end because it will take a longer time. So just let you know the how this traditional virtual work technology compared to the previous three. So we are going to conduct more user study to prove which one is better in certain technologies or application. So yeah, that's it. Thank you for your watching.